Let's begin to finish the last problem of problem set 1. Let's create a folder called credit. Let's go into the folder. Inside the folder, let's create a file called credit.c. Let's go into the folder and start writing our initial code for C. Okay, now let's start solving our problem. The first step is to create a function that will receive a positive integer as its input. Let's initialize a long int and call it number. Let's create a function whose output will be a long int, and let's name it get positive int. Let's initialize a long int num. Let's make it so that a do while loop is run, and inside the curly brackets I could write num equals get long number while number is less than 0, and let's return number. Now let's go on to here, printf %li \n number. Let's check our code, make credit. Initialize number. Oh, we haven't called our function. Let's create the prototype of our function atop our code, and let's call our function over here. Go into the code and try again. Make credit. Okay, it's functioning credit, and it does call for a number. So give it, prints out the number. That's what we want. Now, our next step is to validate the number. Let's try to understand the Luhn's algorithm using this example. Look at this number. In this number, we have to isolate the numbers that I have underlined from the numbers that I have not underlined. Let's assign position to these numbers starting from the back to the front. Now, if you look at it, the numbers that I have underlined have even positions, while the numbers that I have not underlined have odd positions. Now, for the numbers that are in the odd positions, we have to isolate them and add up every number. That is, here we have to add up 2 plus 7 plus 6 plus 0 plus 7, and we get 22. As for the numbers in the even position, we have to multiply each number by 2. 0 multiplied by 2, 5 into 2, 9 into 2, 8 into 2, and 4 into 2. Then we will get the results. Then we'd have to split the results if they are a double-digit number, as here 5 into 2 is 10, it's a double-digit number. You have to split the double-digit number into single digits, and do so for every other double-digit number. Now we have to add up all these digits. Let's add them up, and the resulting is 25. Now add the sum of the numbers in the even position as well as those in the odd position, that is 25 plus 22, and we get 47. Now we have to check the last digit, that is 7, and 7 is obviously not equal to 0, and hence this is invalid. It cannot be considered as a number for a credit card. That's how the Luhn's algorithm works. In order to validate the number, we'll first need to get the individual digits of the number. Let's create a for loop and say that I will be equal to number, and I, this equation will continue as long as I is greater than 0. The for loop will continue. Inside the for loop, let's say that int y will be equal to I modulus 10. Using modulus, we are able to get the remainder. Here the number I will be divided by 10, and we will get the remainder. And if a number is divided by 10, then the remainder will be the last digit of this number. So this is a convenient way for us to get the last digit of our number. Let's create another variable called digit counter, and let's make it so that this digit counter increases by 1 every time our for loop is run. Now we have to make a provision so that our for loop will come to an end. For that, let's divide I by 10 every time the for loop is called. When a number is divided by 10, as I is an int, during division between integers, C will not consider any value beyond the decimal point, as a result of which the number will continue to shrink, and when it reaches a single digit number, the division of a single digit number 10 will result in 0, and hence I will become 0 at the end. The next step is to find every other number starting from the second digit. How might we do this? we have updated the digit counter in order to do this. Okay, let's learn how we can split up the even numbers. As you can see, this is the number from the previous example, and the numbers in the even position need to be split up. To do this, let's use digit counter, which denotes the position of these numbers. Now, if digit counter modulus 2, that is the remainder of digit counter divided by 2, is equal to 0, then that means that it is a number in the even position. Okay, now let us run a for loop where int z is equal to y into 2, and it will run as long as z is greater than 0. Inside the for loop, let's add up all the even numbers. That is, for the previous value of even, which was initialized to 0, we will add up z modulus 10. Let us consider an example where y is equal to 5. Then here, when y is equal to 5, z will be equal to 10. And here, z modulus 10 will yield 0. Then we will continue on with the function, and z is equal to z by 10, which will be 10 by 10, which is equal to 1. Then it will continue on the function again. Here, z will become 1, and 1 modulus 10 is 1. Why? Because for the modulus function, if the number to the left of the function is less than the number to the right of the function, then the result will be the number to the left of the function. That is 1. And 1 will continue on the algorithm, and 1 divided by 10 will be 0. It will be 0.1, but in C, for the integer data type, 0.1 will be considered as 0, and hence our for loop will be terminated. This is the code that will split up 5 into 2, that is 10, into 0 and 1. Okay, that's all. If digit counter modulus 2 is equal to 0, that is, the remainder is 0, means that these are even numbers. If it is not 0, it means that they are odd numbers. Let's create another variable called odd and make it 0. Let's make it so that odd is equal to, let's make it so that the digits whose corresponding number is odd will be added on. Let's begin writing our for loop. For int z equal to y multiplied by 2 should continue as long as z is greater than 0. Let's create another variable called even and assign it a value of 0. Now inside the for loop, let's make it so that every time it is called, even z modulus 10 will be added on, and z will be updated by dividing it by 10. Okay. After doing that, we'd have gotten our numbers, we'd have gotten odd and even. Now, at the bottom part of the code, let's create another int called sum, and let's make it so that sum is equal to odd plus even. Now, let us create another variable called last, and last will be equal to sum modulus 10. This will mean that last will be equal to the last digit of sum. As we know, if the last digit of sum is equal to 0, if last is equal to 0, then that means that our function has satisfied the condition. Else, we can print f invalid. Now, if last is equal to 0, then we need to write a function that will figure out the type of card. Even if the last number will be a 0, there is a possibility that it might not be an actual card number. So we need to write another function that will validate if the number provided is really another card number. So let's create another function, void card name function. Takes input, but it has to take the input to take int num. Digit counter counts the number of digits that are inside our initial input. So we can calculate the card to which the number belongs to with the help of the number of digits. So if int number, that is the digit counter, let's call the function int number is equal to 15. If the digit number is equal to 15, then we can print f Amex, American Express, else if number is equal to 13, you can print f visa. Visa. Else if the number is equal to 16, if it can be a MasterCard or a Visa. If it has to be a Visa, it has to be 16 and the first digit of the number should be 4. So there must be a function that, so this function should also receive the first digit in first as an input. So let's write first is equal to 4, then it should print Visa. Now, what for MasterCard, the first two digits needs to be from 52 to 55, 51 to 55. For MasterCard, the first two digits need to be from 51, 52, 53, 54, or 55. How can we create this? For that, we have to receive an input of the first two digits of the initial input. So else if second is equal to 55, 51, copy, or 52. Let's use the or conditional and create options such that for any of these values ranging from 51 to 55, the condition will be met and it will be declared as a MasterCard 55. If these conditions are met, then it means that the card is from MasterCard. It is MasterCard. Now, there are other conditions to be met for a card to be declared as Amex as well. If I don't understand. Let's create an else. We might have made a mistake because for this if loop, we have to create an else over here. That is, if it is not 15, if it is not 13, if it is not 16 and 16, then it should print invalid. Invalid. Okay. Here, if number is equal to 15, but it has to be equal to 15 and it has to be equal to 15 and the second digit should be equal to, the second should be either 34 or second should be equal to 37 for the number to be declared as an Amex card. For Visa, it should be 13 and the number should begin with 4. Okay, so we have made the function that will decide which card, we have made a function that will take in 3 inputs and will use those inputs to figure out the company of the card provider. Okay, let's declare our function. Let's create the prototype of our function. At top our code. Main void. Let's create a prototype of our function. Now we have to find out the first two digits of the input number and the first digit of the input number. Let's create in first 0. In first digit equal to 0 and in second digit equal to 0. let's try to find the first digit. To find the first digit, while this is running, for the first digit f, what will be the value of I? For the first digit, the value of I should be a single letter. That is, if the value of I yeah, when this for loop is running, as it will be the turn of our first digit, here this will produce I equal to 0. I divided by 10 for the first digit will produce 0, and hence our loop will be stopped. So here we could just say that if I ever becomes, or we could say that I greater than 0 becomes false, then first digit is equal to the value of y at this point. Okay, so we have declared first digit, and I believe that this code will get us a first digit. Now, how will we find the second digit? For our next step, let's create a function that will give us the first two digits of our initial input. Let's say that long int. The output of this function will be a long int. This function name can be second digits. The input will also be a long int, that is the initial input. We'll call this function. How will we get the second digit of this number? Let's say it will be long int I. Let's say that long int second digits is going to be equal to I. Then let's create a while loop. That while second digit is greater than or equal to 100, we will run a function that will divide the second digit, that is effectively shave off the last digit till it becomes a 2-digit number. Now we can return second digit. Let's create a prototype of our function out of our code. Let's make it so that the second digit is equal to a long int second digit is equal to second digit call our function. Both have the same name. Let's just add an s. Digits, second digits, get second digit, get second digit, get second digit, and get second digit. Let's call our function, and for its input, let's pass in number. That is the initial input that we are getting. Okay. After passing in number, it will run number. And we will be able to get the second digits. Now, inside this f, that is, if the last digit of the sum is equal to 0, let us call our card name function and pass in the values of digit counter, first digit, and second digit. Okay, let's make credit, and this time there are no errors. Let's code credit. There is no output. Why is there no output? This is run inside the for loop, so it is called every time. You can't run it inside the for loop. This is inside the for loop. That is our error. You have to take it out of the for loop. Make it out of the for loop. Now let's run our code again. It was an invalid number. Now let us run check 50. And that's it. Our code has worked, but there are a few cases where our code has not worked. Why? Let's run our code and find our mistake. Make credit. To find our mistake, we can use the printf function. Let's use printf to print out printf die second digits. Let's print out every value that can cause our algorithm to fail, and we'll be able to understand why it did so. Digit counter. It's actually these are not master card. Thread is invalid. Why? You have to use the debugger in this situation. Just go into it and select points where you want it to stop. Go into it. I want it to stop here when updating the digit counter. I want it to stop when updating even. I want it to stop when updating odd. And I wanted to stop updating this. I want to stop when updating this and this. It's not working. You can run debugger. Okay, now let's give the number. Let's look at it. In sum equal to what? Odd is equal to 0, digit counter is equal to 0, everything is equal to 0, second digit is 55. I get it. Number, the issue here is that number is a long int and what I had inputted was an int. Okay, let's make credit once more. Let's call credit. Let's input the number and we have it. Let's run check 50 once more. A / problems / 2026 / x / credit. So the takeaway from all this is that if we are using a for loop and passing on a number whose data type is a long int, then you would have to declare a long int within the for loop. If you don't do that, the for loop will never be called, and as such, when the input is a 16-digit number, my code wasn't working. Now look at it, it's working for everything. So that's it, guys. I am doing CS50 and I'll be sharing my solutions to all the problem sets in order to inspire people, and it is mainly done so that I'll be accountable, and the idea that I'll have to upload after finishing each problem set will motivate me to finish the problem set. I was having difficulty with being consistent in things, and I hope that it helps me, and I hope that some of you who are struggling with consistency and who want to go on a journey to better themselves will hop on with me and try to become better versions of ourselves. So that's it for now. Thank you.